Good afternoon, students. After completing the matrix part, now the next part is determinants. So actually in this chapter, what we have to discuss, mainly the first point, properties of determinants. Second, minors and cofactors. Next, application of determinants. That means where we use these determinants. Mainly in area of a triangle to find out the area. Then adjoint of a square matrix. So in matrix again we apply this determinant. Next, inverse of a square matrix. So in our matrix part we know how to find out inverse with the help of elementary operation. Easily we can find out the inverse. So here another method is there to find out the inverse. Next, consistency and inconsistency. Next, solution of a linear equation. So that means this linear equation is not same as like class 10. So with the help of matrix method we have to find out the solution. So in this determinant part mainly we have to discuss these topics. Is it clear? So now first of all, determinants. Actually determinant we get from matrix, and matrix already we know there are different types of matrix are there. Mainly if you consider a square matrix and a rectangular matrix. So in determinant only from the square matrix or only square matrix have determinants. Is it clear? That means the meaning is what? In case of this matrix here, only the square matrix we consider here, and from this square matrix we find out the determinant. Is it clear? Remember, only square matrix. So that's why at first here we write square matrix. So here not taken the rectangular matrix. So now if you see here we consider a square matrix. So square matrix of order 1 by 1, 2 by 2, 3 by 3, 4 by 4 or whatever you taken. So first of all what we have to do, we consider matrix of order 2 by 2. So that's why we consider A, B, C, D. So if you convert this one into determinant, that means this determinant we can write like this symbol. Remember, this one is not a modulus of A, so that's why here written you see determinant of A, it is not a modulus of A. So that means this one is not a determinant, not a modulus of A, it is determinant of A. Is it clear? So next, this determinant of A also we represent by determinant of A like in this way, and now the symbol is this one. This one is not modulus, this one is the symbol of determinant. So if you find out the difference between matrix and determinant, is it clear? So determinant of A we represent by like in this way. Is it clear? So here mainly two notes are we write here. Only square matrix have determinants, and the first one is, second one is, it is known as determinant of A, it is not a modulus of A. Is it clear? So now here we discuss about the properties of determinant, minor, cofactors. So mainly first of all the determinant, what the determinant is of the order 1 by 1, 2 by 2, 3 by 3. Let's see how can we find out the value of the determinant actually here. Is it clear? Okay. Now here the determinant of a matrix of order 1 by 1. So now here we consider an example. We consider a matrix A. You see here we consider a matrix A of order 1 by 1. So of order 1 by 1 means obviously there how many elements are there? Only one element. So if you find out the determinant of this matrix, so we have to use this symbol determinant of A. So determinant of A means determinant of A on this we write. So here only one element is there, so that's why the result is value is same. Here the value is what? A. From the determinant actually we find out the value. Similarly, if you consider another example here, a equal to suppose 2. So here the order is 1 by 1. So if this matrix a equal to 2, then the determinant of a equal to the value is actually what? 2. So in this way, for 1 by 1 matrix, easily we can find out the value. Is it clear? So after that, now determinant of a matrix of order 2, that means 2 by 2. So in this case, we consider a matrix again. You see here 2 by 2, that means total 4 elements, 2 rows, 2 columns. So in this case, we represent this one, these elements are here. So now we have to find out the determinant of this matrix A. So determinant of A equal to, if we write the symbol here, determinant of A, we just put the value elements here. So the elements are we put. Now after that, how can we evaluate the result? You see here, by cross multiplying. By cross multiplying means what? We start from the first row, first column. So the first row, first column here A11. So that's why if you see here the red mark, so first row, first column is A11, then we multiply with A22. So that's why we write A11 into A22. And here, according to our formula, here minus come, and then we write A21, A12. Is it clear? So this one is the process to find out the value of 2 by 2 determinant, isn't it? So a matrix given to you, and from here easily we can find out the determinant. So let's take an example here. If you see this example, suppose 2 4 minus 1 2 if given to you, so you have to find out the value of this result. So easily we can find out. So here the first row, first column is 2, so that's why 2 into 2 minus, according to the formula minus come, then minus 1 into 4. So ultimately the value is what? 8. I think all of you understood this. Is it clear? Okay. Next one is very important here. Determinant of a matrix of order 3 by 3, or you can say order 3. So in this case, obviously, when we find out 3 by 3 order means 3 rows, 3 columns. So that's why we consider this one is the determinant. Suppose we find out the value of this result. So now here, if you see, in case of matrix already we represent, so the same thing here also we can represent here. So R1, that means the first row, R2, that means the second row, R3, that means the third row. Similarly, C1, C2, C3, first column, second column, third column. Is it clear? So now here, how can we find out the determinant? So in 1 by 1, directly the value, the whatever the element is the given answer, we find out. So in the second case, when we find out the 2 by 2 matrix, when we consider 2 by 2, then we have to cross multiply, isn't it? And for 3 by 3, how can we find out? So in case of 3 by 3, you can first choose any one row or any one column. Remember, not diagonally. Is it clear? So you have to choose any one row or any one column. Your choice. You may choose row 1, row 2, or row 3, any one row or any one column. So here a note given, for easier calculation we shall expand the determinant. So that means we have to expand this result actually. And how can we expand? We expand the result along that row or column which contains maximum number of zeros. I think all of you understood this one. So later on you know why we choose this one. So now here, first of all, we discuss here how can we expand this result. Suppose we expand this one, expanding along first row, that means row 1. So here we expand the result along R1. So that's why here we write expanding along R1. So how can we write this result? Let's see here. So when we expanding along R1, so the first row, the first element you see here, what is the first element? 1 1. What is the position of this element? First row, first column, isn't it? So that's why here we represent by 1 1, or you can say this one is first row, first column. So according to the formula, what you have to write, minus 1 to the power 1 plus 1. So this 1 plus 1 represent first row, first column. So that's why we write 1 plus 1. Is it clear? So minus 1 to the power 1 plus 1 means here first row, first column. And then after that, this one is the formula. So that's why we write this one. And then after that, we write A11. That means here this element we have to write. The first row, first column element we have to write here. Is it clear? Okay. After writing this one, Now if you see here, again you see, so this A11, this one lies on first row, first column. So which one is the first row? This one is the first row. And which one is the first column? This one is the first column. So we have to eliminate these two in our mind. Suppose if we eliminate these two part, first row this one, first column this one. So we have to eliminate these two. So if you eliminate these two, so what you get here? So we have to eliminate this one, this part, and here we have to eliminate this one, first row, first column. So what will remain here? You see, A22, 23, 32, 33. This one remain. So we put this result as it is here, you see. 22, 23, you see here, it is 22, 22, 23, 23, 32, 33. Is it clear? So this one we put here. I think all of you understood this one. Then next, the same process we have to apply for second one. So the expanding along R1, so that means the second element is 1, 2. So plus, so that's why we have to write minus 1 to the power 1, 2 means what the meaning? Or if you just remember, this one is first row, second column. So that's why minus 1 to the power first row. Always we have to write first row, row plus column, 1 plus 2. Is it clear? So here the element is A12. So that's why we write here A12. And after that, again the same process. So first row we have to eliminate, and as it is we have to eliminate the second column. So what will remain here? If you see, if we eliminate these two, so what will remain here? A21, 23, 31, 33. So that's why these four results we have to write. Is it clear? So that's why this one we get. In this way, if you find out the third one is here first row, third column. So that's why we have to write minus 1 to the power first row, third column. And the element is what? A13. So in the same way, we have to eliminate the first row and we have to eliminate this third column. So what will remain here? 21, 22, 31, 32. So this one we have to write here. I think all of you understood this one. And after that, the next step, all of you know. So here now this one we convert into 2 by 2 matrix, so easily we can find out the value. How can we find out? This A22 we have to multiply 33 minus 32 we have to multiply 23, and then if we evaluate, then we get the answer. Is it clear? The same process we have to apply here, and then in this way we can evaluate the value of this 3 by 3 determinant. Is it clear? Okay. Next, let's take an example here. Generally, we have used this symbol for determinant. Is it clear? So now here, this one is the determinant given to you of order 3 by 3, 3 rows, 3 columns. So we have to find out the value or evaluate this result. So there is a process for easier calculation. We have to check out the maximum number of zeros. So if you see here, the maximum number of zeros are here in the third column. So we have to expand this one with respect to the third column. So that's why here written expanding along C3. So if you expand along C3, so from the first, this one we have to start. So what is the position of this element? 4. First of all, we have to write down the row and then column. So that means this one is first row, third column. So the position is what? 1, 1, 3. So that's why we have to write here, you see, minus 1 to the power 1 plus 3. And then we have to write the element 4. And after eliminating, putting this element here 4, we have to eliminate this 1 to 4. And then we have to eliminate this part. Then what will remain here? Minus 1, 3, 4, 1. Isn't it? So that's why we have to put there minus 1, 3, 4, 1. And for the other two, 0 into something, obviously you get 0, 0 into something, you get 0 here. So that's why we write these two. Without doing anything, we can directly write here 0. Is it clear? So that's why we choose maximum number of zeros in which column or in which row present, this one we have to take in. So now here expanding along C3, if you calculate this result, you get minus 52. Now if we choose another row or column, then let's see what you get. Here using the third column, you get this minus 52. And if you expand along R1, or you can choose R2, R3, any one row or column you can choose. So here if you expand for 1, the position of this one is what? First row, first column. So that's why minus 1 to the power 1 plus 1. Then element 1, and then this column row cancel. So this 4 we write here. Then 2. What is the position of 2? First row, second column. So that's why minus 1 to the power 1 plus 2. Then we write 2 into 2, and then this to eliminate we put this. In this way we write. So here also what we get? The answer is minus 52. So from here what we can say? So in case of determinant, when you evaluate, if you are expanding along C3 or if you are expanding along R3, whatever you choose, for all determinants you get the same value. You see here, for when you are expanding along C3 you get minus 52, and if you are expanding along R1 then also we get minus 52. That means if we expand this result expanding along R2 or C2, then also you get the same value. That means minus 52 you get here. Is it clear? So in this way we can expand 3 by 3 determinant. I think all of you understood this. So now here, after completing this, if you see the exercise 4.1, if you see the exercise 4.1 here, you see very easy questions are here, so easily you can solve. So 4.1, the first one is you have to evaluate. What you have to do? You have to just cross multiply the result and then find out. Similarly here, trigonometry function, no problem, you can easily evaluate. So in this case also, if you cross multiply, then easily you can evaluate. So in question number 3, what you have to do? First of all, you see matrix given, then so that we need to prove this result. So in this question, what you have to do? You have to find out the value of left hand side as well as you have to find out the value of right hand side. So 2 into a, so that means first of all you have to find out twice a. That means if you multiply any scalar with matrix, then with each and every element we have to multiply. So first of all you have to find out twice a value, and then you have to find out the determinant value. Is it clear? Now here 4 into determinant, that means here you have to find out the determinant value and then multiply with 4. Is it clear? So the same thing we have to do here also. So these two questions easily you can solve. So evaluate the determinant. So evaluation process, already we know the method, so easily we can solve these two, isn't it? So if you see the next question, then here also we have to evaluate, then here find a, that means we have to evaluate the value, determinant of a. Next one is, you see here, now question number 7. So in case of determinant, what happened? When we have to find out the value of x, you have to cross multiply these two first, twice x into x, then minus 6 into 4. Similarly you have to cross multiply and then you have to calculate the result. From here you find out the value of x. But in case of matrix, what happened? So it is 2 by 2, here it is 2 by 2, so easily we can compare. So comparing is possible only in case of matrix. In case of determinant, what you have to do? You have to evaluate this result, and then solve it. Is it clear? So the same thing you have to do here and same thing you have to do here. And in this way you can complete this exercise. I think all of you understood this. And your task is what? You have to complete this exercise 4.1 as well as the example questions are also. Is it clear? So if you complete this exercise and example questions, then in our next class we start properties of determinants. Is it clear? So this one is very important part. In our next class we have to start properties of determinants. So before properties, all of you complete this exercise 4.1. Is it clear? Okay, thank you.